So now we've talked about domain and vertical asymptotes, as well as a little conversation about holes in graphs. And then the next part of the conversation, until we can actually graph a rational function, is horizontal asymptotes. So just like there's vertical asymptotes, there's also horizontal asymptotes, but these are way more confusing. So horizontal asymptotes are still invisible lines, but this time they're invisible horizontal lines that certain functions approach, but this time they can sometimes cross, which is kind of confusing. So a vertical asymptote you will never cross, but a horizontal asymptote can sometimes be crossed and sometimes not be crossed. So when you're thinking about finding horizontal asymptotes, you can find them as x approaches infinity and negative infinity. So not as x approaches like a certain point, like 3 or 1, but as you just approach infinity and negative infinity. So if we look at the same function, that f of x is equal to 1 over x minus 3, as x approaches infinity, so as we make this number bigger and bigger and bigger, your y value is going to approach 0. Now it's never going to technically be 0, but it's going to get pretty darn close. Like here, when x is 1,000,000, your y value is 0.000001. So it's getting pretty close to 0, but it's never going to quite get there. And then the same thing as x approaches negative infinity, same idea, your y value is approaching infinity, or your y value is approaching 0. If you look up at the graph here, what we're looking at is a horizontal line at y is equal to 0, and you can see that the graph is approaching it. Now this asymptote is not going to be crossed. Okay, really the only times that you cross it are when there's x-intercepts, and your horizontal asymptote is that y equals 0 line. So just have that in your head. But the other confusing thing about horizontal asymptotes is that there's more than one scenario that determines what type of horizontal asymptote you have. So when you're determining a horizontal asymptote, it's all dependent upon the degree of your numerator and denominator. So scenario 1 is when the degree of the numerator is the same as the degree in the denominator. Now, to find the horizontal asymptote, you would take the leading coefficients of the numerator and denominator and divide them. So for here, the leading coefficient is a 3, and the denominator, the leading coefficient is a 1. So your horizontal asymptote would be at y equals 3. So you can see it's drawn on this graph here. And again, this is an asymptote that you're approaching and you are not crossing. The next type is when you have the numerator as a lesser degree than the denominator. So if you have something like x minus 4 over x squared minus 4, then the nice thing about this one is that the asymptote will always be y equals 0, no matter what. It doesn't matter which one you circle. So for these types of functions, the asymptote, the horizontal asymptote, will always be y equals 0. And the nice thing is, because this one's so consistent, these are the only graphs that we are going to sketch. So we are only going to sketch these scenarios where the denominator is greater than the numerator and the horizontal asymptote is y equals 0. And the reason for that, the reason it's y equals 0, is that if your denominator is bigger, then you're always going to have something divided by something bigger. And so you're going to be approaching 0. The third type is when the numerator is 1 degree greater than the denominator, in which case you get an oblique or a slant asymptote. So that's like one that's an equation of a line. And to find it, you actually do the division. You would do 2x squared minus 3x minus 1 divided by x minus 2. And I could show you synthetic division or long division to prove this to you, but you end up with 2x plus 1. And that would be the equation of your slant asymptote. But we are not going to sketch these. And lastly, if the numerator is greater than the denominator, well, I should say when the numerator is greater than 1 degree greater than the denominator, then you don't get a horizontal asymptote. So these are your 4 options for horizontal asymptotes. The only one we are going to do is number 2. We had to cut it somewhere. Sketching rational functions is super complicated, so let's just take one win. Now the complicated thing about these ones is because the horizontal asymptote is y equals 0, these can be crossed with an x-intercept. So these can be crossed if there's an x-intercept, which we will discover when we start sketching. All right, that's it.